Hello, everybody. This is the second part of the C9 recap that underpins C10. In this very short video, we're going to look at the energy level diagrams for both endothermic and exothermic reactions and look at how we can interpret them. We're also going to look at that lovely exam question that often comes up, which is where they talk about how you can describe endo and exothermic reactions in terms of the energy in bond breaking and bond making. So first of all, we're going to look at endothermic reactions. Endothermic reactions always follow the same profile. In other words, we always look at the reactants and the products. If it's an endothermic reaction, it means that heat is being given from the surroundings to the products. Therefore, it makes sense that the products must be higher on the energy level graph than the reactants, because this delta H here, this delta H, all that energy has gone into the products. And in order for it to go into the products, it has to come from the surroundings. That energy has to go in from the surroundings to make the products higher. The EA is what we would call the activation energy. Activation energy is always positive because you always have to put energy in order to hit the activation energy. If you didn't have to put energy in, then a reaction would be spontaneous. It would happen without any kind of energy input whatsoever. So EA is always positive. It often comes up on the MCQ questions, and you are able then to rule out 2 straight away, because if the EA is negative, you rule that answer out. It cannot be that answer. In an endothermic reaction, this delta H always has to be positive, which makes sense because the delta H talks about the change in energy of the chemicals. So if the chemicals have more energy, then that's because the surroundings have less energy, therefore your delta H is always positive. How we can describe this is we can say that the energy absorbed for bond breaking is less than the energy released by bond formation. And that makes sense because if you added up all of the energy, if you added up all of the energy absorbed for bond breaking, then it would be much less than the energy released by bond formation. So that deficit has to come from the surroundings because this side is less. So the deficit has to come from the surroundings. If we have a look at exothermic reactions, completely the opposite. So in this case, the energy is going from the chemical system to the surroundings. It's being given out. Again, EA will be positive. So even though it follows a different profile, EA is always positive because you always have to put energy in. Reactants and products are different this time. The reactants are higher in this case. It's a really quick self-check. When you first look at an energy level diagram, you should be able to tell instantaneously whether it is an exo or an endothermic reaction. Because the products are lower than the reactants, then this delta H is negative because the delta H talks about the change in energy of the chemical system. If the chemical system has lost energy, then it must have given that energy out to the surroundings. We say the energy absorbed for bond breaking, or the energy put in for bond breaking, is greater than the energy released by the bond formation. Okay? That is exo and endothermic reaction energy level diagrams in a nutshell. All you need to know. See you in the next episode.